My name is Emmanuel Paiko, a postgraduate student of our vocational technology education program. I work at Tafawa Balewa University, Bauchi, Nigeria. You are welcome to Foundry Workshop. Come with me. Foundry shop is a place where metal is melted and poured into a mold to get a desired shape, which is known as metal casting. In foundry work, various types of metal casting exist, which includes permanent mold casting, otherwise known as die casting, shell mold casting, investment casting, green sand casting, dry sand casting, plaster mold casting, and centrifugal casting. For the purpose of this exercise, we'll be focusing on green sand casting only. For a couple of moments, I'll be taking you through 6 lessons in sand casting. First, safety rules in foundry shop, sand casting equipment, pattern and pattern making, steps in making a mold, melting and pouring of metal, shaking out, cleaning, and finishing the cast. Lesson 1. Safety rules in foundry shop. Objectives. At the end of the lesson, you should be able to 1. Correctly enumerate safety rules and regulations in a foundry shop. 2. Correctly observe safety regulations in foundry shop. Safety is a very important component in foundry work. Foundry workers are required to strictly observe safety rules in the foundry shop, for these rules provide protections to both users of the workshop as well as the facilities. Avoid horseplay in the workshop. Always keep the foundry workshop clean. All inflammable material should always be kept far away from sources of fire. Never leave any cast or hot metal where someone might step on or touch it. Always know the location of fire extinguisher in the foundry shop. Always use the correct tongue for the lifting of crucibles from the furnace. Whenever molten metal is to be carried, it should never be too far from the ground level. Always wear proper protective clothing such as fireproof apron and hand glove, glasses or shield when working with molten metal. Always use the correct grinding wheels when finishing a cast material. Always ensure that the face of the grinding wheel is used for grinding large cast materials. Always use a vise or any clamping device to hold piece of cast metal while it is being machined. Lesson 2. Sand casting equipment. Objectives. At the end of the lesson, you should be able to 1. Correctly enumerate the various tools used in sand casting. 2. Appropriately define the use of various tools used in sand casting. 3. Clearly identify the various sand casting tools. 4. Appropriately use each of the various tools used for sand casting. Flat molding board. This is a large flat board made of wood. Usually, the pattern is placed on it and then the flax to form the desired mold. Flax. The flax is usually a box made up of steel, cast iron, or sometimes wood. The top half is called the cope, while the second half is called the drag. It is used for holding sand in the mold, which in turn hold the molten metal until it solidifies. The sieve or riddle. This is used for sifting the facing sand over the pattern. Sprue pin. This is a round tapered wood or a metallic pin for making runner in the mold. Riser pin. This is a round tapered wood or metallic pin for making the riser hole in the mold. Shovel. A shovel is used for scooping the sand until the correct mixture is achieved and for filling of the flask. A rammer. This is for compacting of sand wall round the pattern in both the cope and drag. Strike or bar. This is a hand tool made of metal or wood which is used to pull across the cope and drag in order to level all the sand, thereby making the surface clean and smooth. A spraying can. A spraying can is another container used for storing water, purposely for mixing of sand. A trowel. A trowel is used for smoothing the sand in the mold. The spoon tool. This tool looks like a spoon and it is used to make gates in the mold. Water brush. This is soft foam for sprinkling of water on any cracked portion of the mold with a view of repairing it. A wire piece or vent rod. This is any steel rod used for making holes on the mold to allow for escape of gases during casting. A bellow. This is used for blowing out particles of sand from the mold. A crucible furnace. This is a source of heat used for melting metal. A smith forge or gas welding torch can also be used for this purpose. Nevertheless, furnace is the best and safest. A crucible. This is a container made of cast iron used for melting metal. Lifter. Lifter is used for collecting of impurities on the surface of the molten metal. It is sometimes referred to as a cleaner. A crucible tongue. This tool is used for lifting crucible from the furnace. Lesson 3. Pattern and pattern making. Objectives. At the end of the lesson, you should be able to 1. Correctly define what a pattern is. 2. Correctly differentiate between pattern and the real casting. 3. Describe the use of pattern and that of a casting. 4. Correctly list the materials used in making pattern. 5. Correctly describe the steps in making a pattern. A pattern is a model or the replica of the object to be cast. It is upon a pattern that sand is packed round to form a cavity known as mold, in which molten metal is poured into it to give a cast object. The main differences between a pattern and a casting are their dimensions and the material they are made up of. Materials used for making patterns. Patterns are made with different materials, among which are the following: wood, metal, plastic, wax. Wood is used because it is less expensive and readily available. Pattern may be single or split in form. It may be simple or complex in nature. The pattern is first marked out, with the pattern made slightly larger than the object to be cast to accommodate shrinkage and machine allowance. The pattern is then cut to shape, filed, and polished. It is therefore ready for producing the mold cavity. Design considerations when making a pattern. In order to produce a good pattern, the following factors must be considered. Pattern must be accurate in dimensions and must have good surface finish. Patterns should be made so that they provide for essential allowances such as shrinkage, draft, and finishing. Another factor to be considered is the number of casts to be produced. The more the number required, the stronger the patterned materials required. Molding sand. There are two types of sand used for making a mold in casting work. These are synthetic molding sand, natural molding sand. The synthetic molding sand is a formulated sand which contains proportions of silica, sand, clay, carbon materials, and water. Whereas the natural molding sand is the sand used as it is dug from the ground, with possibly only water added to it. Properties of molding sand. For molding sand to be effective, it should possess certain desirable properties such as cohesiveness, permeability, refractoriness, strength, durability. Cohesiveness, that is the ability to retain shape when squeezed. Permeability, that is the ability to provide paths for escape of gases. Refractoriness, this is the ability to withstand high temperature. Strength, this is the ability to carry the weight of the metal which is used. Durability, ability to be used and reused repeatedly. Lesson 4. Steps in making a mold. To correctly make a sand mold, you should select a molding box, flask, which can accommodate the pattern. Place the pattern over the turnover board. Place the drag over the pattern with pattern surface down on the turnover board. Sprinkle the facing sand carefully around the pattern. Fill the drag with molding sand. Ram the sand uniformly in the molding drag around the pattern. Strike off the excess sand to bring it to the same level with the drag. Turn the drag over. Sprinkle pattern powder over the top of the drag. Place cope over the ram drag using the dowel pins. Erect the sprue pins and riser pins to form a channel for pouring molten metal. Fill the cope with sand and ram it carefully. Remove the sprue pins and riser pins. Strike off the excess sand from the top of the cope. Separate the cope from the drag. Remove the pattern from the flask. Cut a gate or a channel leading to the cavity. Repair the mold if necessary. Blow out particles in the mold. Close the mold by placing the cope over the drag. Now, the mold is ready for the pouring of molten metal. Lesson 5. Melting and pouring metal. At the end of the lesson, you should be able to 1. Identify various sources of melting non-ferrous metal. 2. Enumerate the processes involved in melting of non-ferrous metal. 3. Carefully melt non-ferrous metal for casting. 4. Safely pour molten metal into the prepared sand mold. In order to successfully heat and melt a non-ferrous metal, one of the following sources of heat is required. 1. Crucible furnace. 2. Hard forge or gas welding torch. The process of melting starts by charging the crucible with scraps of aluminium, lead, brass, or copper. These must be large enough to provide enough molten metal that will fill the mold cavity. First, the metal must be heated until it attains the melting temperature. It should be noted that overheating of the metal will normally produce poor quality casting. Next, add the flux and stir to remove slag or impurities on the surface of the molten metal. Then take the crucible pot out of the furnace and put it in the crucible shank. Carefully carry the crucible pot to the desired location of the mold and begin the pouring. Pouring of the molten metal. In order to do this, carefully and rapidly pour the molten metal into the mold. Once you start pouring, continue until the sprue hole is filled up. Stop pouring as soon as the riser hole remains filled up. Keep face and body away from the mold to avoid inhaling the rising steam. Lesson 6. Checking out, cleaning, and finishing the cast. Objectives. At the end of the lesson, you should be able to 1. Correctly enumerate the processes involved in checking out, cleaning, and finishing the cast. 2. Correctly use the tools and equipment to finish up the cast for good appearance. Shaking out. This is simply the process of removing the cast from the mold after it has solidified. This process is done either by hitting the boxes, punching, or vibrating to break the sand. The next thing is fiddling, which refers to cutting off the riser, runner, and other extensions on the cast to give it a good appearance. To do that, remove the gates, riser, and the runner from the cast using hand file, hacksaw, or portable grinder. The next thing is pickling. This is done by using chemical solution to remove the sand on the surface of the cast metal. Then it is further cleaned with blast or compressed air. Lastly, it is then stored in an open air for a period of time. This process is known as withering to restore back the grains. At last, here we are. Our work is completed. From the pattern to the cast metal, as you can see. Using the same process, various components and parts can be cast, such as ATBU logo, which I'm holding, and the anvil.